Double-digit thousands.
Okay, so now to get started, okay, so what is it, the agenda that we're going to discuss is basically I'll just walk you guys through the what, why, and how of DevOps so that we will have an understanding what exactly is DevOps and why the organizations are focusing towards this, and in this, what is that we are going to do. Okay, so I'll be basically touch basing these areas in a simple way and not to get into too much of jargons in a way that a layman can understand. So that's what I'll be doing. And just to give an introduction about myself, my name is Adam and I'm a software generalist by profession and technical trainer by passion. So now, before we get in and understand what exactly is DevOps, let's try to understand what is the need of DevOps. So from an organization that if you try to look, basically now because of the heavy competition in the market, as an organization, there will be a lot of pressure for them to take care of the existing business as well as try to acquire new customers. So in that way, now because of the evolving technology in one side and the pressure of the competitors in the market, now as an organization, whether they are trying to work on a product or whether they are trying to take care of maintenance of a service, now regardless of what kind of task that they want to deliver, the focus of them is how is that they are going to do the delivery as soon as possible. That's how, if it is a product which they are trying to release, how quickly can they release it into the market before the competitor? And in case if it is a service that they are maintaining, how quickly can they deliver the service to the customer, or how quickly the customer can use their services? So that is the most important thing that they have to focus on, delivering the results of whatever that they are taking care. Along with the faster delivery, they should also focus on keeping the quality of whatever the task that they are delivering to the customers or to the end users should be as high as possible. Because now, just because you want to do something in a fast phase, you cannot just say that you have to put down the quality. So along with the delivery time, we also have to focus on the quality as high as possible. Now, is that only thing what an organization needs? Now, if you see, one of the major problem why organization come into the mode of recession is they put too much of cost into something unexpectedly, and that is when they have to make sure that they are reducing the cost, and by cost cutting they will ensure that whatever profit that they are going to get will be adjusted. So in that way, now by driving things in a fast phase and to ensure higher quality, they cannot put too much of resources in terms of machines or in terms of people that you're going to work on it. So that is when the focus that they also should have is how much of the cost that they're going to put into the production or maintenance will be reduced. So that is the major task that they will be focusing on, because now just by doing things in a faster way and keeping the quality as high as possible, if an organization puts in too much of resources and spend too much in it, then the selling cost of their product or the service will always be high. So once again, there will be a problem in the market. So that's when the cost also has to be reduced in terms of production or the maintenance. And finally, in terms of outage, so when I say outage, it is the duration within an organization where you are trying to do an upgrade of your system or a maintenance of your application, because of which none of the applications or the machines are working, and either the production has been stopped or the end users cannot access your service. So that kind of duration is what we call it as outage. So when you have an outage, your production is absolutely stopped, as well as the end users cannot access your service. So that is going to be a major drawback for an organization. So that's when, as an organization, they are also going to focus majorly on how do we ensure that the outages will be reduced as much as possible. Because the problems that we are going to get in an organization is inevitable. You cannot just say that none of the machines will fail and you don't have to take care of any kind of upgrade. It is going to come, but how effectively are you going to take care and make sure that all these kind of outages will be a non-descriptive, which means there will not be much impact to the user and they can do their activity as usual. So that's what an organization will be looking at the current market trend. So in that way, now they have to do something to get these factors done. And what is that they have to do? Basically, they have to take care of some action, and who is going to work on that? It will be the engineers within the organization who will be doing all this release task or the maintenance task. So that way, now within an organization, you can broadly classify the engineers into two groups. One is the development group, the other one is the non-development group. So when I say the development group, it will be the set of people where people like developers or programmers, QA engineers, performance engineers, release engineers, product managers, documentation engineers, pretty much anyone who will be responsible or working in releasing a product will be part of this development group. And on the other side, the non-development group will be a set of users who will be taking care of all the machine requirements which these users have, and also taking care of a application will be part of this. So in that way, the non-development group, generally we call it as a operations or a administration group. And who will be part of this? System administrators, network administrators, web administrators, database administrators. So anyone who will be taking care of a machine or an application will be part of this group. So now let us see what are the problems that these groups are facing, and as an organization, what is that we have to do to achieve the requirement from the organization. So that way, if you take the first group, that is the development group, basically they will be following certain software development lifecycle. And in that, a simple way what they will be doing is, there will be a bunch of developers and their task is to write code day to day. Now, when a particular developer completes his work, he will be doing a unit test to verify his changes are fine. And once he has tested, he has pushed it to the QA so that they can do a complete functional testing. But for a QA to do a complete functional testing, they need the entire product. And when I say a product, it is not just going to come from one developer's change. So various developers who are working on the product, when they have completed all their work together, when we integrate, and we will be able to create a product. So in that way, it is not possible that all the developers will be completing a work at a given point of time. So if one developer has completed his work, he has to wait until all the rest of the people who will be working on the same product has to complete the task, and then after they have completed the task, you will be going to integrate that together and then create a product. So at this point, if you see, there's a lot of waiting period that we put from the developer as well as the QA to integrate all the changes. So now let's say that you try to integrate at some particular point of time, and you take all the changes that has been done and go ahead and create a product and verify. So that's when, while doing a testing or deploying your system, you might face an error. And once again, when you see, it is not a one developer's change that you are trying to verify. There is a couple of developers who have verified, you have done a lot of changes which you are trying to integrate and verify. In that way, now we have to once again spend some time in figuring out what exactly has caused the problem and what and all are the problems that is there. Because the system is going to fail at the very first occurrence of an issue. So now, finding out what exactly is causing and going back to the developer and asking him to fix will once again take some effort. Now, if you see, literally, if a developer has to do only a small change, he has to wait for a longer time to find out that his change was not compatible as a product, and he has to do that. So ideally, he has been waiting for a long time and then trying to know this. So In that way, now it is not just one bug that we will be finding out, but let's say there was one more problem in the same set of changes, but we didn't find. Why? We stop the system whenever we see the first failure. So that is when, in order to find all the bugs and get it fixed, everything, and then give it for a release, it is going to take a long duration for us to complete the software development. So that is when we have a major problem in terms of the quality in determining all the problems, as well as the time which is going to be taken for a longer duration. Is that the only thing what they are going to do? No. Why? Because along with the standard lifecycle development for a particular product, they will also be doing some parallel releases, or they will be taking care of some bug fixes which they have already released in a previous version. So that way, along with the existing task, they also have to do so many parallel releases and the development cycle for that also. So that is when the pressure on the development group will be high, where the major pain points they have is how is that they can reduce the cycle time, that is the release cycle time, as well as how can they ensure that they find all the bugs as soon as possible and keep the quality of the product as high as possible. Okay, now if you focus on the operation group or the administration group, so you will be having the administrators where they will be taking care of a machine specific to what activity they are doing. And now in that, their primary responsibility is to make sure that the machine or the application that is running on them is up and we are able to access it. So that is the primary task that they have to do. But along with it, they will also be responsible to do certain maintenance tasks. So maintenance tasks like creating user accounts or allowing users to access some particular application or a machine, and then taking of backups of the application data or the data in the machine itself, what a user has, and think about doing some software upgrades or the system upgrade, making sure all the libraries are available. Or in case if someone comes up and says that, hey, I want to install this software or this utility on this machine for my particular task. So you're going to take care of all those kind of deployments. So like this, there will be a lot of maintenance tasks which they have to do, which will be specific to a machine. Now, each machine that we have will be unique in terms of architecture and in terms of the application or the service that we are going to use in them. So it is not going to be the same task which they will be doing. And along with it, it is also equally important where we have to focus on the health of the machine. So what do I mean by health of the machine? So if you want to do some task and you have a machine, if that machine is accessible and the application is accessible, is that the only thing sufficient for us? No, because what happens, you are able to connect to the machine and you are able to run your application, but the application is taking a long time to complete in terms of performance, or it gets hung, or let's say there is no enough resources like no space or no enough RAM to run your application, there is a network failure. So if you have any kind of such problems, then the machine is not healthy to perform the task what you wanted. So that is when it is equally important that these administrators have to ensure that these application and the machines are healthy. Okay, so now as I was saying, the number of tasks that they will be doing will be unique on each machine, and as the usage keeps growing, the number of machines that they have to take care will be huge, as well as the number of maintenance tasks that they have to do on each of the machine will be huge. So from that way, the major pain point what the operations or the administration group will be focusing on is operational excellence, which means how effectively can you handle hundreds of machines that you have in your lab or data center, and what is the cost that you're going to use for the maintenance is reduced, and ensuring high availability and high accessibility of machines and application. So that as the end user, if he wants to connect to a machine, the machine should be there and the application should be there, as well as you should be able to continue your day-to-day task on it without a problem. So taking care of all these things is what we call it as high availability and high accessibility. So with these problems that an organization is having, how is that they can achieve the goals that they need in terms of faster delivery, ensuring the cost has been reduced in the production or maintenance, quality of whatever they are doing, the releases will be high and outages will be reduced. So that's when, as a solution, organizations are moving towards a culture called DevOps. And DevOps is actually going to act as a bridge between these two individual groups, that is the development group and the operation group. And in this, what is that you're going to do? So DevOps is actually, once again, a culture. A culture means a mindset where rather than working in silos, we put a collaboration between these two groups, that is the development group and the operation group, where we will be working together collaboratively in such a way that in that we will be focusing on as much of automation through which we will be trying to achieve all the problems that we have as an organization. Okay, so in that way, DevOps is a culture which will be driven by an organization. It is not something which you are going to focus on a particular tool, or it is not going to focus on improvement on a particular process or a problem area that you have in your organization. Whereas as an organization, it is such a culture and a mindset change where rather than working separately as development group or operation groups and focusing on automation only on that area, you are going to work together as a single group where we will work collaboratively and try to provide end-to-end solution in which focus on as much as automation that is possible. Okay, so such a kind of culture is what we call it as DevOps. So people don't understand this, wherein they think that it is specific to a tool or it is specific to a particular problem that you have. For that, you give a solution using some tool and it is DevOps. No, it is more from the organization's requirement where they are going to work in a different culture in which both the development and the operation groups are going to work together. Okay, so that's what is a DevOps. Now, as part of DevOps, what is that we are going to do? So by collaboratively working together as a single group, wherein the development group will also focus towards the administration side of the machine, whereas the administration group will also think about doing some automation and taking care of the development lifecycle. So such a way where both work together is what we call it as DevOps. And in that, the culture change is about bringing in some new modern software methodologies, following some best practices, and going ahead with some open source tools using which you will be doing things faster and at a lesser cost. So in that way, now, since the organizations nowadays will be using the agile way of software development, now what they will be doing is they'll be breaking the complete product on which they are going to work into smaller and smaller components, and further these components can be classified or divided into smaller and smaller tasks, and all the stakeholders of that release in terms of the developer, QA, build engineer, and the program manager, they will work together in a cycle called sprint, and in that they will try to focus to solve a particular future or fix a future as soon as possible. So that way, now by adopting a software development process called continuous integration, what we will do is, as soon as a developer completes his work, immediately you will integrate it with all the other changes that you have in the product and create a product and go ahead and do the verification. So that way you continuously integrate for every developer's change, create a product and verify. That way as soon as a developer completes his work, immediately you are going to verify. So by this, the bug detection will be immediate and a developer doesn't have to wait for a longer time. Okay, so not only that, the quality of the product will also be high because you are trying to detect the problem as early as possible. Okay, now by this way, what is going to happen is the productivity will be high because you are reducing the time in detecting the bug, as well as you are trying to find more bugs and keeping the quality of your product in case if there is actually a problem without waiting for a longer time. And not only that, if needed, you can also extend the same process to do a continuous delivery process or a system where as soon as the developer completes his work in continuous integration, what we do, you take that code, integrate with other changes, create a product and test. And when you are going to test, it means that you have already created a product. And if needed, you can go ahead and do a deployment to a production so that the end users or your stakeholders can use it. So that way, adding the continuous deployment of the deliverables what you have created as part of continuous integration is what we call it as continuous delivery or continuous deployment process. So by that, we will always be able to focus on parallel release and achieve the release cycle as soon as possible. Okay.
Sorry to disturb you, Adam. I have a question.
Yes.
This is Charan. Yeah. So actually, in this slide, you are saying about continuous integration, right? Let's assume there is a sprint. Okay, in a sprint, there are multiple sprints which is dependent on each other. Okay, so you said a group of a small bulk of work is divided into small pieces called sprints, right? So there are multiple sprints which each and every sprint is dependent on the other. Okay. So a bunch of developers is working on sprint 1, sprint 2 and sprint 3. Okay. So now there is sprint 1 which the group of developers who are working on sprint 1, they have completed their task and ready to deploy. Okay. So as sprint 2 is dependent, if we integrate that, after creating the packages and deploying that, so how that is going to work? But in this scenario, how it is going to helpful actually? My question is, they have to wait until the second sprint is also going to be done, right? So in that time, in this scenario, the same amount of time they are going to take until they have to wait until the second piece of work and third piece of work has to be done, right?
See, when you're talking about a component level dependency or a future level dependency, yeah, definitely you cannot proceed without completing phase 1. So let's say you have different futures in different phase. Now, if you want to focus on that, and if you have a dependency of one phase with another phase, then unless you don't complete one phase, you cannot go. But you can do parallel development. And the point what I'm trying to say is not from the product level, but more from an individual developer. So now for a particular sprint, let's say you have 2 to 3 developers who are working together. Okay, now let's focus only on one sprint. In that way, now, do you have to wait until for a particular sprint, all the developers will complete the work and integrate? Or as part of continuous integration, what you can do is take only that sprint, and for that, as soon as the developer completes the work, you can go ahead and immediately integrate and change. So that is why focusing on cycle by cycle or sprint by sprint, you can focus minute level in such a way that as soon as the developer or an individual developer completes its work, he doesn't have to put in a lot of effort in waiting. So that's what I meant. But as a product level, if you have a dependency, then only after you complete the sprint, you can go ahead with the next sprint. So that is something which we cannot fix it directly, but we need to understand on what is the dependency. So based on that, we can do parallel development. But now the focus here is when you're working as a group, you don't have to wait until everyone is completing. So that's the point of continuous integration, where for each individual developer's change, you can immediately test and verify by doing the continuous integration process.
Yeah, okay. Thank you.
So now, like I was saying, DevOps is not just focusing on one area. It's going to focus on both the process of the operations and the administration. So that's when the other major side which DevOps focuses on is the effective way of doing the infrastructure management. In that, now, if you see, for having new requirements, you will be creating new machines. Now, for new machines, either you have to purchase a new machine, which is going to put on too much of cost for you. So that's when earlier the administration group were creating virtual machines, that is machine within a machine, and trying to solve the problem in terms of cost. Suppose if you want 5 machines, what you're going to do is, rather than procuring 5 physical machines, you're going to create 5 machines virtually inside a machine using virtualization concept or using some tools like VMware or HyperX, using which you can do the virtualization concept. But as in DevOps, you are going to focus on things beyond it in terms of not just solving the problem of bringing the machine, but how effectively are we maintaining it? What is the effort that is needed for maintaining? And for maintenance, what is the resource that is needed? That is also that we need to focus. So that is when, if you look, creating many machines and maintaining in virtualization is going to take a lot of effort. And also, it is going to take a lot of resources in the terms, if you want to install a hypervisor like a VMware or HyperX on a particular machine, then you should have a huge resource machine. So that is when you can run many VMs. But again, as you want to run more and more VMs on it, then you have to keep on adding more and more resources. That is the major problem where now on the maintenance part, what DevOps focuses is to introduce an advanced level of OS level virtualization through concept called containers. So using these containers for whatever system requirement that you have, you will be effectively creating many containers within the same machine, and it is also not going to take too much of resources because it is quite light in weight. And in addition to it, for various automation that is needed by the development group, now you might have to replicate the complete environment. By saying it, in VMware or in any other virtualization concept, you cannot replicate the same VM so quickly. Whereas in containers, you can quickly replicate one container into many containers and you can use it as different machine. So that's the advantage where using the containers, you'll be doing a higher level of OS level virtualization. Now, talking on that, now there is something called as cloud computing, which is also part of infrastructure management. Now, because of the drastic changes in the technology and too much of automation which we are focusing on and trying to solve the problems as quickly as possible, that is how as an organization you make sure the outages are reduced. So primarily, what are the kind of requirements that an organization will have for a project to release? Now one thing let's focus is, let's say that you have a machine on which you have an application running. Suppose suddenly if the machine crashes or some problem happens in it and you will not be able to use your application, right? So what is the solution that you will have to do? Now you have to bring up another alternate machine, and in that you have to set up the same tool or the application on that, or move the application from that machine to the new machine. Now this is going to take a lot of time, correct? Now as you have more and more machines and more applications, the failover concept will also be little hectic to maintain, because for everything you have to have one more backup machine on which you are going to set up everything. So that is one problem. Now what if, assume that your complete lab is on a power outage, then you cannot have a backup machine at all, because now if one machine goes down, you can immediately try to set up one more machine in the same lab and try to solve the problem in moving the application. But I am saying, what if there is a power outage on your complete lab or your data center? Then you can't do anything. Then again, it's going to be a complete outage throughout your organization. Now, that is one problem. Let's talk about one more problem where your organization is trying to provide a service and that service is being used as an application by different customers. Now suddenly you see that there is a drastic usage of your application or service, and because of this, the application which is running on a machine, it is not able to withstand the load. So you have to add more resources so that you can distribute the load from that particular machine on your doing. So now, whenever such a request happens at that moment, you have to effectively jump on and try to add a new machine to the infrastructure. So that way, no matter what kind of advanced virtualization concept you are going to do, still it requires some kind of maintenance effort, and you cannot just do the things on that instant. For an example, if you're trying to connect to Facebook, so let's say suddenly you have millions of users connecting to it, and if Facebook goes slow, they will not just say that please wait for some time, we will add more machines so that your process of web access will be quicker. Immediately they have to do something at that instance, right? Because even a minute delay is going to be affecting their service. So that way, what is that they have to do through which they can effectively maintain the infrastructure? And take the same scenario in a reverse way. In a reverse way now, which means, okay, suddenly you see that you have a heavy usage for which you did some maintenance and you brought by adding new machines. But now, if the load goes down, the machines, whatever that you have configured and you have used, is still going to be running. Now, whether you are going to use it or not, you are going to have to pay for the maintenance in terms of power and the effort in what you have put in setting it up. So that way, now, when your application is scaling down, whatever resources that you have, it still is going to be idle. So that's when there's a cost involved in it also in terms of power. Now, for solving all these problems, the cloud computing comes into the picture where we don't have to worry about setting up an infrastructure. So without even having a lab, or even if you have one single machine for you, it should be sufficient where you go to the cloud service provider where through the internet or online, they will be giving you machines as and when you need, where they have their own data center set up, so that if you want 10 machines, you quickly go to them and get 10 machines without spending much time and quickly set up everything. And let's say you suddenly don't want it because of lesser load, then you don't have to pay for everything, because give back all the machines which you are not using. In that way, the cost is quite effective. And mainly, you are not going to take care of the infrastructure. So they will take care of the infrastructure, because now you are just going to access the machine and work on the application. If that machine goes down, it will be the responsibility of the cloud service provider to bring up another machine where they will be replicating the data. So they will take care of those kind of load balancing and the services for high availability. So that's the advantage where organizations are looking at cloud, where they can set up the infrastructure and maintain it effectively over there and majorly focus on getting the services done quickly and reducing the cost. And now, regardless of whether you are accessing a physical machine or a machine virtualized or a machine on a cloud, as a user, you have to do some task, right? Not as an administrator, but as a user. So for doing different tasks, different user will require different kind of configurations to be done on it. So that's when, how is that we can still effectively do the maintenance and configuration of all these machines? So in DevOps, we are going to go through a process called configuration management, where it will effectively help us to ensure the configuration on all the machines that we have in the lab, which could be hundreds to 1,000 machines. We can effectively manage and make sure the machine is in the right state for all the users. Okay, so you want to install something, you want to update something, you want to take a backup, everything can be done and automated using configuration management. And finally, DevOps doesn't focus on this. It also ensures that each and every machine and the application that we are working on should be monitored, wherein you will be seeing what are the resources that the machine has and what resources that the application needs. Is it everything fine? Keep a track of it. And in case if you see a problem, you proactively try to solve it whenever it is a small, because after some time when it becomes a big problem, it will be a bottleneck and it will take a lot of time. So that's when being the DevOps culture or the way that you focus, you will be proactive in finding the problem and trying to reduce so that you don't have to think about putting a huge outage to fix the problem. Okay, so now if let's say that as an organization we are focusing towards this DevOps culture wherein they want certain engineers to follow this culture wherein you will be called as a DevOps engineer, what is the characteristics that as an organization they will be looking at, or as an individual what are the characteristics that we should have? So the major thing is we have to be a generalist. So when I say generalist, we have different kind of problems coming to us wherein a problem could be in the development side or on the testing side, or it could be on the quality, or it could be on the administration of a machine, or setting up an environment or a configuration. So regardless of whatever problems that we have to be a generalist and be ready to solve the problem. Okay, so that's when the initial part when I said DevOps is a mindset where we don't just keep ourselves within one way of working, because now so far we could have been a developer, or we could have been a QA person, or we could have been an administrator or a build manager. Now the culture that we have to adopt is we have to come out of that mindset and be ready to solve problems which could be anywhere in the development cycle, or it could be anywhere in the infrastructure management. So how are we going to solve these problems and how ready are we is what we have to be. That is what we call it as a generalist. And then the DevOps characteristics is that you will be trying to implement some best software processes like continuous integration and continuous deployment, through which whatever changes happen, immediately you verify it and create a deployable system and put it onto the production so that the end users can access. And do a continuous monitoring where all the applications and the machines that we have in our lab or the data center which we are trying to use will be monitored proactively, and any kind of problems that we foresee will be tried to fix immediately. And one of the important characteristics along with this is resilience, which means it's not about just finding a problem. How quickly are you going to fix it? And when you are going to fix, how effectively are you going to communicate to all the stakeholders saying that this is the problem that we are facing, and for that this is the alternate solution that I'm going to give, and as part of that what are the steps that you're going to give? So that's when in DevOps it's all about collaboratively working between various stakeholders and effectively communicating to all of them. Okay, and in that, how do you ensure to bring back things to its original position is what we focus towards the resilience. And majorly, DevOps is all about automation. So now you're going to focus on different kind of problems, and for that, how is that you can put in automation and try to reduce the time and reduce the cost involved in it and bring the quality as the best. Okay, so now comes to the point that what is that we have to do as a particular engineer, because as an engineer, what is that I'm going to do and how is that I'm going to implement all these things? So that's when for these different problem areas or the processes that you're going to implement, we have set of tools specific in it. So now using that set of tools, you will be providing an automation or a process improvement where you will be working on a particular tool or a combination of various tools through which you will be providing the automation for a problem or creating a pipeline to solve the problem. So that way for focusing, I mean, let's say if you're focusing towards implementing continuous integration process, then you have various tools to help join different kind of activities, that is on the version controlling for development, and for build management for creating a product, and for doing effective testing on code quality analysis. So all those things, again, you have different tools like Git, Maven, Jenkins, and SonarQube, through which you will be creating a continuous integration cycle. Now, if you're also focusing on continuous delivery, then we have tools specifically like application servers, or you have Artifactory storages like Nexus and JFrog, where you can use it connected to the continuous integration process and do the deployment also. if you're focusing towards automating the configuration requirement through configuration management, then we have a lot of tools like Chef, Puppet, Ansible, using which you'll be providing the configuration requirement. And if the focus is towards the virtualization requirement, then you will be using Docker, which will be going to give us the containers, that is the OS level virtualization. And now, for doing all those things, if you want to set up a complete new infrastructure, so that's when we have the cloud service providers like Amazon Web Services or OpenStack, using which you will be planning the complete infrastructure. So when I say complete infrastructure, it's not about just the machine. What is the machine that you're going to have, and what applications are you going to run in it? How is that you're going to allow the users to run in terms of access and the security, and how is that you're going to interconnect everything by providing a network? So all these things, including the machine, hardware, and the software and network, is what we call it as the infrastructure. So you're going to focus that using the tools in cloud. And if we have to think about setting up a continuous monitoring, then we have tools like Nagios for Splunk, using which you can set up and monitor each application and each machine that we are going to use. And in that, scripting plays a vital role on the DevOps automation, because it's not just the tool that we have to focus. There are many activities that we will be doing as part of our day-to-day task. So to help us in automating those kind of tasks, we will be using scripting. And also, some scenarios, there will be some tool on which you will need some additional functionality specific for your product or organization. So that way, you can use a script to write some kind of scripts or a wrapper on top of the existing tool, or try to connect different tools to create a process and do some more automation. So that's how scripting also plays a vital role. Okay, so coming down to the last point, what is that we are going to do finally? So now, depending on what is the problem area that an organization have, you are going to set up a workflow as part of the DevOps culture, in which you are going to work on various tools and provide a complete tool chain. And in this, now if you focus, DevOps workflow is all about right from the beginning, a developer is going to start his work on coding to the point where you are going to deliver the product created and given to the customer, as well as for that, whatever machine that is needed, and how is that you're going to maintain and monitor that. So that is on, depending on different process, you will be working on a different set of tools. But in such, DevOps is now going to focus on completely both the sides, from the release as well as on the infrastructure requirement. So that's how you'll be working together to set up a workflow, wherein as an organization now, what is their goal that they have to do? So based on that, we will be working or extending the workflow from the beginning to the end, whatever that we can see here. Okay. And finally, now for those, what does that have to begin with? Because now, okay, I've been talking so much. What is that you need to understand? What is that you have to learn? So now for someone who's getting into the DevOps, majorly, they have to understand the different problem areas that I was talking about. So that is when the more you know, it's always the benefit for you, because an organization can make use of your skill to solve any kind of problems. That's when you try to be a generalist. Okay, so that way, as a curriculum, you will have to be focusing on all the mandatory and the essential areas where an organization is looking for help in different kind of problem solving areas. So that's what we'll be doing as a part of a curriculum. We'll be focusing on major problem areas, and in that we will try to understand by choosing any one of the tool, and we will go through that particular tool in a scenario based approach and try to understand. Because when you say DevOps, it's not a tool. So you will have a tool today, and tomorrow there will be some other better tool will someone else will come up with. So that way you need to understand what is the problem that you're trying to address, and how is that you're going to fix by using a tool is the next thing that you're going to do. Okay, so that's the focus as a course, that you will be trying to learn and understand all these different kind of problem areas, wherein as an organization they can make use to work on any of that based on their requirement. So that's what you have to be ready to understand. So at the end of learning this, you should be in a level where you'll be confident to take up any kind of problem and try to provide an automation by working on different set of tools. All right. So that's what I had from my side. Any questions or queries?